Next, now the net magnitude of vector A bar. Now the net magnitude of vector A bar along x-axis is given by, so already we know that value of vector A bar at the center M is a suffix x plus dou a suffix x by dou x into dx by 2, and the value of A bar at the center N is a suffix x minus dou a suffix x by dou x into dx by 2. Here the net magnitude of vector A bar along x-axis. So final value minus initial value. So what is the final value? A suffix x plus dou a suffix x by dou x into dx by 2 minus, this is final value, minus of initial value. A suffix x minus dou a suffix x by dou x into dx by 2. In next step, a suffix x plus dou a suffix x by dou x into dx by 2 minus, this value is minus a suffix x plus minus into minus plus dou a suffix x by dou x into dx by 2. So minus value plus value cancel. Here we have two terms, 2 into dou a suffix x by dou x into dx by 2. 2 cancel. Only we get dou a suffix x by dou x into dx. This is the, what is the value? The net magnitude of vector A bar along x-axis. This value from initial value subtract from final value. So final value minus initial value. This is final value and this is minus initial value. When we subtract, we get the dou a suffix x by dou x into dx value. So this is the net magnitude. Next, the total flux. The total flux along x-axis. The total flux. The total flux along x-axis. Along x-axis is given by dou a suffix x by dou x into dx into this one multiply with dy into dz. Already we get the value is this one, dou a suffix x by dou x into dx. So this value multiply with dy into dz. So dy and dz are dimensions along y comma z directions. The total flux along x-axis is given by dou a suffix x by dou x into dx into dy dz. Similarly, along y-axis and along z-axis we can write. Similarly, dou a suffix y by dou y into dy into dx into dz. Similarly, z-axis we can write dou a suffix z by dou z into dz into dx dy. So these three equations are total flux along x direction, total flux along y direction, total flux along z axis. Next, total flux diverging equal to total flux diverging equal to dou a suffix x by dou x plus dou a suffix y by dou y plus dou a suffix z by dou z into dx dy dz. According to definition of the according to according to definition of according to definition of divergence, so dx into dy into dz value equal to 1. Dx into dy into dz equal to 1. So divergence of a bar equal to del dot a bar equal to, we can write dou a suffix x by dou x plus dou a suffix y by dou y plus dou a suffix z by dou z. This is the divergence of a vector field. Okay. For this, first we have to take small rectangular vector field with dimensions are dx, comma dy and dz. In this, consider vector a bar at the center of the vector. At the center of the vector. Its center point is C. With components along x comma y comma z directions, a suffix x comma a suffix y and a suffix z. After that, consider that some flux is entering the pipe through the phase EFGH. We have two phases in that rectangular vector field. So some flux is entering the pipe through the phase EFGH and diverging out of the pipe through the phase PQRS. So in this travel, while traveling from the point C to M, so center point to M in phase PQRS, the change in A suffix X is X is given as dou A suffix X by dou X into dx by 2. After that, the value of vector A bar at the center capital M is A suffix X plus dou A suffix X by dou X into dx by 2. Similarly, the value of A bar at the center capital M is given by A suffix X minus dou A suffix X by dou X into dx by dx by 2. So one is final value and one is initial value. One is final value, that is at center M is final value and at center N is initial value. After that, we want to get net magnitude of vector A bar along x-axis. So for that value, we have to subtract initial value from final value. Initial value from final value. We get dou A suffix x by dou x into dx. This is the net magnitude of vector A bar along x-axis. After that, the total flux along x-axis. The total flux along x-axis is given by dou A suffix x by dou x into dx. So this is multiplied with dy into dz. After that, similarly, we can write y-axis and z-axis. So y-axis total flux dou A suffix y by dou y into dx dy dz. Along z-axis is dou A suffix z by dou z into dx dy dz. After that, total flux diverging equal to dou A suffix x by dou x into dou A suffix y by dou y plus dou A suffix z by dou z into dx dy dz. So according to definition of divergence, dx into dy into dz equal to, what is the value? 1. So that value is 1. We get divergence of A equal to del dot A equal to dou A suffix x by dou x plus dou A suffix y by dou y plus dou A suffix z by dou z. So this is the proof of divergence of vector field. Divergence of vector field. Next, physical significance of divergence. Physical significance of divergence. physical significance of divergence. In this first point, the physical significance of divergence of a vector field is that it gives the amount of flux. It gives the amount of flux per unit volume diverging from that point. So what is the first point? The physical significance of the physical significance of divergence of a vector field is that it gives the amount of flux per unit volume diverging from that point. So the physical significance of divergence of a vector field is that point. It gives the amount of flux per unit volume diverging from that point. So for example, if V bar represent the velocity of a fluid, then divergence V bar gives the rate of flow fluid per unit value. So what is this example? If V bar represent the velocity of a fluid, then divergence V bar gives the rate of flow of fluid per unit value. Next to last point. If the divergence of a vector field is zero, then the corresponding vector is corresponding vector is called as solenoidal vector. So if the divergence of a vector field is zero, then the corresponding vector is called as solenoidal vector. That means if del dot A bar equal to 0, then this vector is called as solenoidal vector. divergence of that vector equal to 0, then we can say that the type of vector is called as a solenoidal vector.